Good morning, everybody.
Good morning, ladies and gentlemen
Good afternoon.
of calculus, pre-calculus.
Morning, California. Not here.
Morning, California. Yeah. Okay, so this exercise set today will go pretty fast, except what I noticed in the fifth period is it kind of, one thing that slowed it down is people had a lot of questions about these things, because what seems really easy to me is not as easy for people that aren't as familiar with this. But what this has to do with, these exercises 13 through 16 state the sign, and so what you're trying to do, it's actually a three-part problem. State the sign, positive or negative, and of sine t, of cosine t, and of tangent t.
What's t?
T is going to be a variable. Okay, t is a variable like x or theta or something like that.
And what does that stand for?
Well, the sine of t. So what happens is, do you notice these? We come back to the posters that Mr. Calvin was kind enough to leave me a couple years ago, right? Do you see this one over here, the lower right one, that says this? It says all students take calculus. Now, is that a true statement? No, it's not a true statement.
I am. I'll be the only one. You will. I'm not taking calculus. That's better.
Yeah, so anyway, that's really, so it's not a true statement, but it's one that's a mnemonic device to help you remember things. And basically what this is telling you is here in quadrant 1, all trigonometric ratios are positive. Here in quadrant 2, the sine, student stands for sine, is positive, but cosine and tangent are negative. Here in quadrant 3, what is positive? So tangent theta is greater than 0. Here sine theta is greater than 0. And here in quadrant 4, what is greater than 0? So cosine theta is greater than 0. And so basically what you're doing is you're remembering all this stuff. So which quadrant is this in here between 0 and pi over 2? Which quadrant is that?
First.
It's in the first quadrant. And I had some questions. In fact, I'm going to get that later. But that's in first quadrant, so all trigonometric ratios are positive, right? So I'm going to put down sine t is greater than 0, cosine t is greater than 0, and tangent t is greater than 0. All those are positive. And what I'm going to do is I plan to call on students to help with these other problems today. How's that? You ready to do that? You're confused? What are you confused by?
What are we doing?
Okay, what we're doing is we're given an angle. Okay, you remember the unit circle of trigonometry? Where we have this unit circle right here. So here's the unit circle. It's right centered here. And this angle here, remember the unit circle trigonometry song? 0, pi over 6, and the next one I know is pi over 4, pi over 3, and pi over 2. So that's quadrant 1. And what happens in quadrant 2? Well, you got 2 pi over 3, 3 pi over 4, 5 pi over 6, then to pi, and then in quadrant. So if you're looking at that, Emily's looking at the unit circle there. If you go down to third quadrant, you have 7 pi over 6, and is that 7 pi over 4, and then is it 4 pi over 3, and then 3 pi over 2,
3 pi over 2, 5 pi over 3.
5 pi over 3, 11 pi over 4, and 11 pi over 6. And so these are all represented here in these intervals. And so this quadrant here is quadrant 1, okay, because it's between the angle of 0 in pi over 2. So there's a pi over 2 angle, and so what we're talking about is angles in this quadrant right here, quadrant 1. Does that make any sense? Okay, she doesn't sound convinced. Okay, anyway, so what I'm going to do is subsequent problems 14, 15, and 16 are from other quadrants in that unit circle. And ideally, eventually I'd like you to be able to do this without a unit circle in hand, but if you are, like I see a few of you have a unit circle out looking at it, that is great. I'm glad for you to do that. Okay, I'm going to pick on somebody for number 14. And number 14, okay, we got...
Is that in here?
It's going to be
Yeah, I'm
Caleb.
not gonna be able to do it.
No?
Because I don't even know what the time.
Well, let me just ask you, I want to work with Kaylee a little bit. Which quadrant is this in here? Second quadrant. So quadrant 2, right? So, in this whole thing, all students take calculus. What does it say in quadrant 2? So sine is positive, right? So you have sine t is greater than 0. What about cosine t? Is this the only one of those three that's positive? Yeah. What is cosine t going to be? Less than 0. And what is tangent t going to be? Less than 0. Now I want to explain that. So that's not that hard, is it?
No, it's really easy.
Well, it's pretty easy once you get a first kind of shock to it. But I'm going to do some more supplemental explanation of that, looking back at this, and I'm going to put a graph inside of the question 53. Have this. Okay, if we go back to this drawing right here, here in quadrant 1, the coordinate pair is going to be a positive and a positive, right? In quadrant 2, what do you have? You have negative, comma, positive. And here in quadrant 3, you have negative, comma, negative. In quadrant 4, what do you have?
Negative or positive.
Positive, comma, negative. And so what you have here in quadrant 2, which is what Kaylee just did, is your cosine is going to be negative, and your sine is positive. And tangent is what? Sine divided by cosine. What is a positive divided by a negative? Negative. And then you can do the similar type of analysis on all these things. I will show you something else too, is that these functions here are graphed, and I'm going to eliminate the tangent one right now. I'm just going to zero that out. So what happens is sine and cosine are right here. And this is set up on this window from negative 2 pi to 2 pi. And these are all at pi over 2. And then these are the y min, y max, and so forth. So we go back to the graph. And this one here is the sine. So here are the angle measures. So the angle measures are the x-axis, essentially. So what you have is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So on this right side, you are working your way around the unit circle. And you see what happens? Here in quadrant 1, you have both sine, which is blue, and cosine, which is red, being positive.
So you're saying like if you took a string around the circle and then you laid it out on the graph?
Yeah, so that's exactly how you could look at it. If you took a string on the circle and laid it out on the graph, that's what this is. And this is actually 2 circles, because this is negative 2 pi, this is positive 2 pi. And at the beginning of the school year, we talked about this briefly when we had Remember that day in class where, actually, I think we did this in 2 days, where I had you take notes of the parent functions of precalculus? You remember that?
No.
You don't remember that? We did. I don't know if you were here, but it was so long ago that you may not remember it anyway. But we talked about the sine function and cosine function. So this is part of, and so what is the utility of these kinds of functions? How could you use these functions in real life? Pardon me?
Frequencies?
Yeah, frequencies. This is like if you look at an oscilloscope, you'll see that exactly. Another thing is anything that's cyclical, like seasons, amount of sunlight, things that tides, anything that uses waves that will go up and down. You can use sinusoidal functions to help model and figure out and predict what's going to happen. Okay? And then the last thing we do, if you have sine divided by cosine, which tangent is, it's this one right here. I'm going to activate it so you can see what that looks like as well. And so here's the tangent. Do you remember yesterday when Kayla was asking me about undefined and all that? Right? This is how we got that. It's because at pi over 2, what happens to tangent? Undefined. Why is that? You can't divide by 0, right? So if cosine is 0, which happens at pi over 2, that's how you divide by 0. So that's how you get these asymptotes. Okay, back here to problem 15. I'll choose somebody for problem.
Can you go back to 14?
Want to go back to 14? All right. Here we go, problem 15. Let me shuffle once, here we go. We're going to have Hannah or Angel. It's going to be Hannah. Number 15, yes. Okay, tangent t is greater than 0. Everybody agree with that?
Yes.
Yeah, I want to show you something though.
Which quadrant it is. I know that that's a coordinate pair.
Yeah, let's go, I want to look at the graph here, because in quadrant 3, we're talking about this looking thing right here. We're talking about this piece right here. So you see that your your sine, which is in blue, and your cosine, which is in red, are both negative. And so you divide a negative by a negative, what do you get? Tangent. So in this quadrant here, which is represented here, you got sine and cosine being negative, but tangent positive. Does that help you understand what's going on?
No, but I'm talking about how do you figure out which quadrant the coordinate pair is?
Well, this right here, maybe it's not clear. This is called interval notation. And interval notation, most of the time you've been used to seeing it in something like this. Negative infinity to 2 to infinity.
Okay.
So what this is these are the intervals from t equals pi to t equals 3 pi over 2.
Okay.
And so if you straighten that out along an x-axis like you suggested earlier, this is exactly what you're talking about. Pi over 2, pi, 3 pi over 2, 2 pi.
Okay.
Okay?
I see what you're saying.
Yeah, okay. So I'm sorry you didn't understand that. But there are a lot of things to think about here, aren't there? Okay, when you're not used to this the way we've done it. So your questions are good, similar to what happened in 5th period. So we're going to have will. Okay, so will is in quadrant 4.
And so that would mean everything is less than the cosine?
Yeah, so you say, okay, so sine t is less than, you say?
Cosine.
And cosine t is greater than?
Yeah.
And tangent t is also less than, right?
Yep. Is that correct?
Okay. Any question? And then it's verified. We go to the calculator, can look at it. This is where it is, right? Cosine is positive. Both sine and tangent are negative. Does it help you to see those graphs like this?
That's a little confusing to me.
One thing I'll do is go to what is your question? Do you have a question?
No, I just don't understand it.
How do you get it?
You don't understand anything of it? Okay, what's happening here is that your variable is an angle. Okay, so it's an angle you have, and over in window, in fact, what I'm going to do is I'm going to restrict the domain of this a little bit. I'm going to make that 0. And what happens is that essentially I'm instructing the calculator to have x vary between 0 and this number here, which is 2 pi. And so what we're doing is we're taking, like Will said, we're taking an angle, which we rotate, and we're linearizing this by making this thing go x from 0 to 6.28. And so we graph these functions here, and this is what the graph of these functions look like. The first one, the blue one, is your sine. The red one is your cosine, and the tangent is the purple one, which is sine divided by cosine. So that's where the functions come from. And so this is what, these values are what the functions do between 0 and pi over 2. And pi over 2 is equivalent to
90 degrees.
90 degrees. So this section of the graph represents quadrant 1. So everything that happens in quadrant 1 to sine, cosine, and tangent is reflected on these graphs here, on these sections of graphs. And likewise for quadrants 2, 3, and 4. So it's just what the numbers are doing of those functions, sine, cosine, and tangent, over this interval. That's all that is. Yeah, but it's a new thing. I know it can be something. Okay, now next, 17 through 20, we're just determining the sign, positive or negative, of the given value without the use of the calculator. Well, I happen to know, for instance, that 143 degrees is in which quadrant? In quadrant 2. Does everybody understand that? Quadrant 2, between 90 and 180 degrees. And so I know that cosine is going to be negative in that interval, right? So the answer to this one, number 17, all it is negative. Okay, so that is our answer to number 17. And likewise, 18, 19, and 20, the answer is just going to be positive or negative. That's all it is.
Is it the y value or the x value?
It's going to be the y value. Let's look back at our graph here.
Okay.
So we look at 143 degrees, which is in here someplace.
Right.
In 143, we see the value of cosine, which is in red here, is negative.
Yeah.
So that's what happens. And of course, it'd be easy to do with a calculator, but it takes a little thinking to do without a calculator, doesn't it? But then, if you look at your unit circle, and for that, we go back here, we could see that 143 degrees is going to be right about here, And so the x value is going to be negative and the y value positive in quadrant 2. So really, the main thing is identifying which quadrant the thing is in. And once you do that,
Can you put the graph back up?
the calculator,
Yeah.
and you can put this on your own calculator too.
Okay.
You know that, right?
There's doesn't have the color, so it's easier to see on.
Oh, it's easier to see on mine because of the color, yeah, that's true. Except if you're like Carmen, no, Carmen, you don't, well, Kaylee, do you have which kind of calculator? Do you have one of those CE calculators?
No, she has a GI.
Okay, but it's colored, okay, so it's like Kaylee, yeah. So, okay, when it comes to that,
In color?
the CE.
So the blue line is,
The blue one is going to be the sign,
okay,
right? And because the sign goes from 0, the value goes from 0 to 1, and then down from 1 to 0, and then down from 0 to -1, and then up from -1 to 0.
yeah.
Okay? All right? Okay, back to the exercise at hand. Tangent, tan 192, that's going to be, it's going to be Angel, all right, Angel. Tangent 192 degrees, positive or negative? Positive. Okay. Any questions about that? No question about it? Katie, you have a question about that? No. All right.
I get how you look at it on the graph, but how do you know just without a graph?
Yeah, I'll tell you.
That's without a calculator.
We just have to memorize what the,
There's really not a whole lot of, there is some memorizing to do, but it's not a whole lot. I'll tell you why. It's because, I'll tell you why it's not a whole lot of memorizing. Because the only relevant angles here, if you go like this, the things you have to remember are so small. You got to remember 90 degrees up here, 180 degrees over here, and 270 over here. And then last thing, this will be 0 or 360. So what you can do is you can look at this, where is this located? Well, it's going to be in here because it's between 180 and 270. Does that make sense?
yeah, I understand that part, but how do you know what's positive from being in quadrant 3?
Well, I know because of the coordinate plane, right? Positive, x positive this way, x negative that way. Y positive this way, y negative this way.
So,
If it's
for-
asking for tangents,
So what you're going to have is you're going to have your x values negative, your y values negative. And so your tangent is going to be a negative divided by a negative.
okay,
And so that's what makes this positive. So that's the mathematics that makes, in quadrant 3, this tangent function positive. Because it is really, actually, the blue thing divided by the, let's see, the red, yeah, it's to be sine or cosine. So it's be that, the blue thing divided by the red thing.
okay,
That divided by that. So here right here at 5 pi over 4, these ones are both negative square root of 2 over 2. So you got negative square root of 2 divided by negative square root of 2, which equals 1. So here, right here, the tangent value is 1,
yeah.
and positive 1 at that. Okay. Okay, next. 19. Here we have a radian measure, and let's go ahead and choose. Yeah, we're gonna have Emily for this one. Okay, what do you think for this one? So she says negative. How did you figure that out? I think that's right. How did you figure it out? You don't know? Okay, go ahead.
So on the circle, there's 3 pi over 4.
Okay.
If you simplify 3 pi over 4, I mean, if you simplify 7 pi over 8.
So right here on the unit circle, Will is noticing this is 3 pi over 4.
Yeah.
And over here is 5 pi over 6, right?
Yes.
And so this will be 3/4, this will be 5/6, and so 7/8 is going to do what? It's going to fit somewhere in here, isn't it?
Yeah.
And one thing you can do is you can convert this into degrees to see exactly what that is. And I think it's like 157.5 degrees or something like that.
So you did that, but we weren't supposed to calculate?
Yeah, that's fine. But I want you to, when it says don't use a calculator, I still want you to work it out without a calculator, but then feel free to use your calculator and check, right? Because then you'll be able to give yourself the feedback that I got it right or I didn't get it right, or if it makes sense. Okay? All right. So that's a good observation. Let's go to this next one. We're going to have somebody else here for this. Who's it going to be? Kayla, Emma. It's going to be Emma. It's supposed to be Emma. Emma's already taken out of it. Okay, Emma, you got chosen. Go ahead.
I got negative.
Negative, she says.
I got positive.
Okay, let's see what this one looks like. Here it is. She says negative. Somebody said positive. This is actually negative because this is what quadrant? Quadrant 2. So that's going to be sine, which is positive, divided by cosine, which is negative, positive. I mean negative. Okay? So that's that one. Now these last 4 today are ones that we don't do very much of in this class during regular course of the discussion. But these are actually multiple choice problems, each one of these. And if you want me to work out number 21,
Yes.
okay, I will show you what that is. This gets back to terminal side. So what this tells you is you have an angle that is right here in what they call standard position. And so this is your initial side right over here. That's your initial side I just drew out in purple. And over here is what we call our terminal side. So this is I'll call it our terminal side. And we know that this angle here is 45 degrees. And so that's what that is. So they're asking which of these is a candidate to be somewhere along this terminal side. And if you're looking, what do you have, what are going to be right here, what do you notice about x and y values along this thing? They're going to be the same, right? And we see that only in one place, which is answer choice A. So A is our correct answer. And if you go to the unit circle, because there's a unit circle that represents here, right here at this point, we're going to have the coordinate pair square root of 2 over 2, comma square root of 2 over 2. But then you go farther out, you're eventually going to come up here at some place and have the point on that ray of 2, comma 2. Does that make sense?
Yes.
Are you able to look at 22 and choose somebody for 22? Okay, go to 22. And we got Kenzie, you got 22? Kenzie's looking like a college student back there. I'll tell you why in a minute. What'd you get for this one? B? Yeah, okay, let's just talk about it a little bit. I think that actually is right. Now we know it's going to be this right here, 2 pi over 3, somewhere like this. Well, we know it's not going to be that. So basically, the signs are right, but which one is the bigger number, square root of 3 or 1? Square root of 3, right?
Yeah.
So it's going to look like this, and B is going to be your right answer.
Mr. D, will you go back so that I can copy down what you had in 21?
Yeah. Thank you, Kenzie. Yeah. Yeah, Kenzie is there. You can't see Kenzie on camera, but she's working this class at the same time. She's also working on another class, trying to pass that CNA exam. When do you take that exam? Okay. All right, very good. Okay, Kaylee, you got that?
Yep.
You got it? Good. Okay, let's go to 23. So we got Carmen and Kayla left. This one's going to be Kayla, all right.
I need a second.
That's fine. The second is about what we have.
A.
A. Why'd you say A?
Because they both have to be negative.
Yeah, you have to have a negative negative in quadrant 3, right? So that's it. Good work. Okay, and we have one other person who hasn't been called on yet. That person is? Yeah, do that.
So if that's positive 6 degrees and negative 6 degrees.
I can't find anything on YouTube.
360 minus 6 degrees.
What do you need to know about this, Kenzie?
Okay, let's go to, okay, Carmen.
Which of the following describes the normal change of aging related to
That's you, Carmen. What is this one here, Carmen?
Vaccine.
Because that one was the last one. Vaccines become less painful.
No, it's not the same.
Not painful.
You're reading B, the response to vaccines.
B?
It's either D or the.
Okay, you have to be a positive, you're in quadrant 4, positive, negative, that's going to be it. Okay, thank you. Right?
Quick finish.